Hello, my dear student. I'm Mr. Kitwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of a rigid a rotation of a rigid board. That is where we are going to proceed for our today discussion. Let us go and see our new subtopic, which is called torque of a rotating a rigid board. Now we are going to see how can we obtain the torque when the body rotating, when the rigid body trying to rotate on its axis. So before we proceed here, now let us try to remember where we ended on the last session. On the last session, my dear student, we tried to see how can we obtain the moment of inertia, and also how can we obtain the moment of inertia by making a relationship between the torque that is given with respect to the angular acceleration and also to the mgh for the compound pendulum. That is what we tried to demonstrate the concept of the compound pendulum. But for our today discussion here, let us go and see the torque of a rotating rigid body. We know that as we know that you are a Form 5 student, our fellow come up and tell you that they have learned about the torque of a rotating of a rigid body. Now, what is the rotation of the torque of a rotation of a rigid body? That is what we are going to try to demonstrate. There are so many questions that need you to find the torque. Now, how can we obtain the torque? Let us go and see the introduction, and after there we should try to see the formula related by the torque. So, torque of a rotating rigid board, as we try to see here. Now, we can imagine that we have the body, and that body trying to rotate on an axis and produce the torque. Now, how can we get the torque? That is what we are going to try to see. So, first of all, let us see the introduction about the torque, and after there, we should proceed with our discussion. So, when we talk about the torque, this is the force required to rotate about an axis of rotation. Now, we want the body, the rigid body, to rotate on an axis. Now, the torque is required because it gives us the force. Kwa hiyo yenyewe inakuwa inatupatia force ili kitu kiweze kuzunguka kwenye an axis in order to rotate on an axis. This is supposed to be the torque. Kwamba we want the rigid body to rotate on an axis. Now, the force should be required because it produces the force. That is what we are going to see. Imagine we want either wale wanaotengeneza magari kwamba labda kuna nati imekataa kufunguka, kwamba anachokifanya ana apply torque. It means anaweka chuma alafu anajaribu kufunguka. Kumbuka ile chuma ambayo anaitumia kuweza kufungulia pale inakuwa na coverage of the distance, and also the force should be required in order to open that skill. This is why we talk about the torque. So the torque rotate or twist an object when it is applied. When we apply this torque, my dear student, it try to rotate or to twist an object when an object. Kwa tunapo apply ile torque, tunajaribu kuitwist ile object, tunajaribu kutwist an object au kurotate kuifanya ile object iweze kubini twisted au ibini rotated on it is an axis. So in general, a torque is defined as the product of the force applied and also the perpendicular distance from the point of the force applied. as I told you that when we talk about the torque, this is generally we can define this must be equals to the product of the force and the perpendicular distance from the point of the force applied. Now imagine kama nilivyokuambia kwamba tunataka labda tuweze kufungua, kwamba tunahitaji tuweze kufungua nati, kwamba kinachohitajika pale force lazima iweze kubini applied pamoja na perpendicular distance ambayo ita-act perpendicular with that force. This is why we say about the torque. So generally you can say yourself, because don't complicate more here. You should know that when we talk about the torque, this is the product of the force and the perpendicular distance from the axis of rotation. That is the definition of the torque. So torque sometimes we say that is a vector quantity. Why we say is a vector quantity? Because it have both magnitude and direction. Kwa sometimes tunakuwa tunasema hii torque ni vector quantity kwa sababu inakuwa na both magnitude pamoja na direction. And its direction is determined by the right hand law. This direction must be identified by the right hand law. We know that when we was in Form 4, we tried to learn on our topic of electromagnetism. We tried to see this right hand law. And the right hand law will say that if we take the skew and we try to rotate, the rotation of the skew indicates the direction of the magnetic field, while the direction the conventional direction of that skew could indicate the direction of the convectional current. Dolo yetu ilikuwa inasema hivyo kwamba imagine tuna nati yetu kwamba nati unapokuwa inaifungua kadri inapokuwa inazunguka inakuwa ina indicate mwelekeo wa magnetic field, lakini inapokuwa inaingia ndani inakuwa inaonyesha direction ya convectional current. Ndio huyu right law alivyosema. Kwa huyu torque inabini determined by using the direction, where we call the concept of the right hand law. And also is perpendicular to both linear force and the radius. This torque is always perpendicular. It acts perpendicular with the force and also the distance. Or sometimes we can say that the distance from the axis of rotation. Kwa hiyo yenyewe inakuwa ni perpendicular with the distance from the axis of rotation. This is how we explain about the torque. So by formula, mathematically we can say that torque must be equals to this distance. It means the perpendicular distance times the force. This is the formula of obtaining the torque, and it should indicate our 70 formula for our force topic here. So it is